Hello everyone and welcome to this lesson. Well, in the previous video I introduced the homologous series and functional groups. Well, homologous series, I said to you that organic compounds are classified as homologous series. Well, yeah, so homologous series are these 9 things. Do not worry about these things. Homologous series are these things. The definition you're going to be asked, you may be asked in an exam, and you should answer it correctly according to the marking guideline. But these are what we call the homologous series. Number 1, alkanes. I've said something about the alkanes before, and you didn't know about it. So alkane is a type of homologous series. It's one of the homologous series. Then it's alkanes, alkenes, alkynes, alkanes, alcohols, aldehydes, carboxylic, this should be acid, carboxylic acid, then esters. These are the 9 homologous series we're going to be dealing with in this whole section. Well, the definition for homologous series previously was it's a group of compounds that can be determined by the same functional group. So consider the homologous series alkanes. The alkane has its own functional group. I don't know if these things are gonna fit here. So each homologous series has its own functional group. Functional group. So for alkanes, the functional group is single. Okay. Let me try and simplify these things for you. Homologous series homologous series are these things. But with functional group, the simple way of knowing the functional group is the functional group actually is the way of seeing the homologous series. So if you want to know what type of homologous series you have for that specific compound, you notice that by the functional group. But anyways, let's continue. So if ever you see single bonds between carbon atoms, something like this, then there's another single bond. If you see single bonds between carbon atoms and that atom has hydrogens only, then those things are single bonds between carbon atoms, and they are telling us that whatever compound that is an alkane. Well, that's the functional group, how we see alkanes, single bonds between carbon atoms. Then moving to alkenes. Alkenes, we see them by the double bond. This double bond between carbon atoms, something like this. See, this is how we notice if a compound is an alkene. Once you see double bonds between carbon atoms, then it's an alkene. Well, these kind of things, they tell you which homologous series you have for that specific compound. Well, with alkynes, you notice them by the triple bond. It's something like this. C, triple bond, then another C, like this. Well, this is the functional group for alkynes. Then alloalkanes. Allo came from the word halogens. Well, we have halogens. We have halogens. 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 So halogens are some things like this: Br, this F, this Cl, this iodine. So these are the halogens we're going to be using here. There's bromine, there's chlorine, there's iodine. So those are the things, the halogens we're going to be talking about, we're going to be dealing with actually in this topic of organic compounds. Well, okay, back to haloalkanes. The word halo came from the word halogens. That it's an alkane, but that consists of halogens. So this doesn't have a specific functional group, but the way of seeing it is by seeing one of these things, or two of them, or whatever. If ever you see this thing, one of this thing, or two of them in a compound, then it's a haloalkane. So C, a halogen. There. That's the functional group for haloalkanes. Once you see one of these things, then that's the haloalkane. Anyways, moving to alcohols. Alcohols. The functional group for alcohols is OH, hydroxyl or hydroxyl. I love calling it hydroxyl. So the way of writing it, okay, the representation is something like this. That's how we see a halogen. I mean an alcohol. Once you see this thing, then that's a halogen. Okay, we'll talk about some things that look like this, but which are not alcohols. Something like, yeah, these two. Yeah. Okay, moving. We have aldehydes. Aldehydes are formyl. That's the functional group, and that's how we see it. It's something like this: C, double bond O, then H, like this. This is an aldehyde, and it's how we see it. Ketones, it's carbonyl. Then I'm keeping saying carbonyl formyl hydroxyl. Guys, these are the names of the functional groups. The names of the functional groups. So the question may come as in, write down the name of the functional group of alcohols, not specifically alcohols. You will be having a table with different organic compounds. So they will be like, write down the name of the functional group of compound B. Once you see that it's an alcohol, you should write hydroxyl for the name. But if they say, write down the structural formula of the functional group of alcohols, this is your answer. This should be your answer. Anyways, with carbonyl, this is for formyl, structural formula. The name for ketones, functional group of ketones, is carbonyl. And the structural formula is going to be like this. Double bond O, then here we should have a C and a C here. These are the distinctions between the functional group of aldehyde and the functional group of carbonyl, of ketones. Of formyl, the formyl has C double bond O, then H. But with this one, there's C double bond O. That C should be attached to another C atoms. So there. Carboxylic acid. The functional group is called carboxyl. The representation is like this. So you see, this ends with an OH, but it has a C and double bond O. Unlike the alcohol is only OH. So once you see only OH, then it's an alcohol. Double bond C, then OH is a carboxylic acid. And so this is how we represent the functional group of a carboxylic acid. So this one, the ester. Well, I have a problem of pronunciation. Anyways, with the esters, it doesn't have a specific name, this one, the name. So I will just write the functional group, the structural formula. It looks like this, then O with a C here and a C. See, they kind of look alike, these two, but this one is double bond O, then O and a C. That's double bond, it's C double bond O and OH. See, this is the difference between the two functional group of carboxylic acid and esters. And so for this lesson, I suppose you have a knowledge of what we'll be dealing with. Anyways, thank you for watching. Just watch the following video. A lot important.